All right, welcome to 2.6 Algebraic Proofs. We'll try to make this one a little faster than yesterday's, or 2.5, so we'll get after it right away. So today, all you're really working on is how do you solve an algebraic problem, okay? And that's how we're going to start. And then we're going to talk about what steps did you take when you did that. And really, we're going to focus on a two-column proof. So just like we did in Centauri's challenge, we did two-column proof, statements and reasons. We're going to do the same thing with algebra. So here's all your steps or properties. You might remember these. I would say these three probably might not remember, reflexive, symmetric, and transitive. But go ahead and copy those three. I think the other ones are there in your note packet for you. You've all done those properties. You might not know that there's actually properties for them, but that's what allows us to do the math that you guys have been learning all these years. So go ahead and copy that down, hit pause, and we'll get going. On the next slide here, all I want you to do is how would you solve this? So pause, solve it, and see what you come up with. So after you pause and after you work this out, hopefully you got something like this. And we get a equals 7. But how did we get there? So what I'm going to challenge you guys here is just kind of follow along here. And let's just make a two-column proof out of this. And you might not have room depending on what you did with yours. But and I'm just using S and R for my statements and reasons. You guys will get used to that. I try to keep that quick and easy for us. But what do we always start with? We always start with a given. We can't do anything if something's not given to us. So there's our problem, okay? And the only thing that would be really missing from this is if it would say prove that a equals 7. So that's what would make it a proof. So that's what we're looking for. So in this case, I just had you solve a problem, see what you did. So what would be our first step? What property did we do? Now, if you have to use layman's term, what did you do? You might just say distribute. Well, really, it's distributive property. Okay? Now, the book likes this next step. They say combine like terms, or excuse me, they say substitution. I think, layman's terms, what did you do? Combine like terms. So let's write that. Combine like terms. What'd you do from, if we label these, this would be 1, 2, 3. So what did we do just from step 3 to step 4? Well, we subtracted 6. So we use subtraction. And then what did we do from step 4 to step 5? We divided by 8, so we used division. And in this case, even though that's not what you started off, but we want a equals to 7, so we proved that a equals 7 in this problem. Okay? Now the next ones you might have to kind of flip through your packet to see, because I kind of moved it around a little bit. I think this is the next one, but I'm going to change this, and I'm just going to move it to this one here. So 2x plus 3 equals 5. So I'm going to start with the statements and reasons here. So 2x plus 3 equals 5. So that's our given. And that's step 1. If we wanted, we could do these different colors. Hopefully my red works. So what do you want to do in step 2? Nope, it's just going to give me black. So we want to subtract 3 from both sides. So we get 2x equals 2. And again, one thing I forgot we're missing on this is to prove what are we trying to prove. Here we're just looking for an answer, so we're not really trying to prove anything yet, but we get the idea. So we just subtract, use subtraction property, and then we'd use division, x equals 1. So again, I'm kind of getting a little ahead of myself. So in this one here, we're trying to prove that d equals 3. So here's where the proof would come, is our last statement, wherever it is, we want d equals 3. Now, one thing that a lot of students like to do with this is they want to substitute 3 in for d. That's the last thing you want to do when you're trying to prove it. When we're trying to prove something, we want our last statement to be d equals 3. We don't want it, in this case, 6 equals 6, because that would be what would happen if we put 3 in for d. That's not what it's asking. It's asking for d equals 3. So down here on the bottom, we need to get to d equals 3, and whatever step that is. They forgot the equals 6 here, so I'm just going to write that real quick. So what do we want to do first? Well, I'd like to get rid of this 4, and what's that 4 doing? It's dividing the whole thing. So I'm going to multiply this whole thing by 4. So whatever I do to one side, I must do to the other. Multiplication property. 3. I'm going to subtract 3. And then we get 7d equals 21. And here I kind of wrote the d equals 3 down a little bit too far. But we would divide both sides by 7. And we get d equals 3. And we just write division here. And that is what we want, or what we wanted. So, okay, so that's how you do an algebraic proof. I'm going to leave you be with this. Try it. Try to do your work. Your assignment problems I assigned you. I think there's like 3 or 4 algebraic proofs. I don't think it'll take you that much long. You can solve it. So try it and come with questions to class. All right. Hope that works out, and we'll see you tomorrow.